Chapter 5, problem number 17. Let's do it. And the picture looks a little weird, and I didn't write my 2 very well. So here we have a mountain climber with a rope at some angle, and she has her feet against the vertical wall at some angle too. And the question is A, what's the tension in the rope? And then the other question was B, what is the coefficient of friction? What's the tension in the rope and the force the climber must exert with her feet? Okay, so this is kind of weird, but let's go ahead and convert this to a force diagram, a free body diagram, and not worry about the different points, right? Because here the thing is that I know that there's going to be a tension going that way. I'm drawing a bad one right now, and I know this is the force from her feet. I'll call that FP. And then there's a gravitational force right there. But let's just put them all together as a single dot right here. So I have the downward gravitational force, mg. I have the tension's going to be pulling this way, T. And then I have this push right there. And I'm going to try to draw it correctly. Now I need to translate my angles. Okay. So first I have this angle is 31. So this angle is 31, so this is 31 right there. Do you see that? Because these are parallel lines, and we have the, what's it called, the opposite angles of parallel lines, and so that's 31. Now over here, that's 15, so this is 15 also. And it's a little tiny, but that's okay. We'll be okay. Now, I already picked my x and y axis, right? And that's the next step. Why did I pick that way? Because that's where my angles are measured from. And in this case, we have a zero acceleration problem, so we don't have to worry about having the axis in one of the directions of the acceleration. So it's fine. Now I can write down Newton's second law as 2 equations. I can say F net in the x direction is equal to 0, in the acceleration, the x direction 0. And then F net in the y direction is equal to 0 also, because the climber's at equilibrium. And you think, oh, well, we can't solve this problem. We don't know these forces. Well, that's fine. That's just, when you can't solve something, you just do it anyway. You just start moving forward. In the x direction, what forces are in the x direction? Well, I have part of the push right here. And then I have part of the tension right there. So, and then I can draw that as up here too. So I can find the components of those. Let's go ahead and write this. This is the adjacent side to that angle. So this is going to be cosine. So the component of the push in the x direction would be FP cosine 15. Now over here, that's the opposite side of this right triangle with that 31 degrees. You could find the angle with the x-axis, but I'm just going to use that one. And so if I have the opposite side, I'm going to use sine. And it's in the negative x direction, so I'm going to say negative t cosine 15 equals 0. Now I don't know FP, I don't know t, so I can't solve that equation. Let's switch over to the y direction. So now what forces are in the y direction? I have all of these. I have some component in the y direction. Let's start with this one. Here's my y component of the force. That's the adjacent side to that right triangle. So it's going to be cosine. It's going to be FP. That's going to be T. T cosine 31. 30. I was just getting into the problem and I wasn't really thinking. Sine 31, cosine 31. Okay, so if I made a mistake one time and someone was working on the problem and then they tried to figure it out, they paused it and tried to figure it out, and it took them a long time, and then they played it and like, oh, he figured out the mistake too. But if you do that, you learned something, right? Okay. So T cosine 31, the y component of the push force is going to be sine, so it's going to be plus FP sine of 15, and then I have the gravitational force minus mg equals 0. So what I have here, I have 2 equations and I have 2 unknowns and I need to solve. So let's just solve this for FP. FP is going to be equal to T sine of 31 divided by cosine of 15, right? So I'm going to add that to both sides and divide by cosine. And let's just get that as a number and make it easier. I'm still here. I'm just getting my calculator, which I don't know where to put it. I'm still here. I got it. Okay, I got it. See, I didn't leave. Okay, so I have 31 sine 15 cosine divided by. So this is going to be equal to 0.533t. Now I can take that and put it into this equation. I'm going to go ahead and write these as numbers too. So cosine 31 is 0.85. So I have 0.857. 0.857t, that's that number. And then I have FP, which is this. I need to multiply it by the sine 15. So it's going to be 0.533 15 sine times, and I get 0.138, 0.138t, and then I'm going to move that to the other side, is equal to the mass, which her mass was 52, times g, which is 9.8. Now I can combine these two numbers together and get a t, and then I can solve over here. So this is going to be t, I'm going to say 0.857 plus that, so plus, I get 0.995 equals 52 9.8 times 509.6. Now I can divide both sides by that, and I get t equals, swap, let's just say divide, and then 1 over, I get 512.1. So I have t. Now I can find the push, because I can go over here, and once I know t, I can plug in my value for t to find F push. So F push is 0.533 times out. 272.9. And that's the magnitude. Okay, so those are my two forces right there. And that was part A. And that had nothing to do with friction, right? So the second part of the question is a little bit more difficult. It says, what's the minimum coefficient of friction? And if you look at this push force right there, it's in the direction of her legs, but it's actually the force from the wall. And so we can break that force into two components. I can say there is a normal force and a friction force, like that. And those two forces add together give me this. So I know the magnitude of FP, and I know the angle. So I actually can say, I can draw it like this, N, which is, it's okay to have N to the side, and F friction, and that's N. And then I can say the friction, I can say the following. Let's write this. I don't actually need T. I need that. I don't need any of this stuff. I just need the F. So our model for static friction says that the maximum static friction is F static is less than or equal to the coefficient of static friction times the normal force. Right? That's what it says. Well, can I find the static friction? Yes. Can I find the normal? Yes. And in fact, I don't even need that number at all. Because if I know this is the angle 15 degrees and this is FP, then I can find an expression for the friction force. I can say Fs is equal to Fp sine of 15. N is equal to Fp cosine of 15. So the coefficient mu s is Fs over N, which is going to be Fp sine of 15 divided by Fp cosine of 15. Oh, look at that. Those cancel. And that's tangent, which you could write it out if you want. So the coefficient of friction is going to be the tangent of 15 degrees. 15 tangent. 0.268. Let's do this one. I did that one already too. Okay, the end. I'll stop right there.